we're asked to find the first and second derivative for the given function. The first step is to write the square root using a rational exponent. The square root of the quantity 5 plus 3x cubed is equal to the quantity 5 plus 3x cubed raised to the power of 1/2. And that's where we're going to determining the first derivative. To find the first derivative, we need to apply the chain rule where the inner function u is equal to 5 plus 3x cubed. So if the inner function u is equal to 5 plus 3x cubed, we need to find u prime, or du dx. The derivative of 5 plus 3x cubed is 9x squared. So now we can just think of the original function as u to the power of 1/2. Applying the power rule with the chain rule built in, the derivative of u to the power of 1/2 with respect to x is equal to 1/2 times u to the power of 1/2 minus 1 times u prime. Or in our case, 1/2 times u to the power of 1/2 minus 1 is the quantity 5 plus 3x cubed raised to the power of 1/2 minus 1, which is negative 1/2, and then times u prime, which we already know is 9x squared. Let's go ahead and simplify. 1/2 times 9x squared is 9/2 x squared, and then we have times the quantity 5 plus 3x cubed raised to the power of negative 1/2. Let's rewrite this using positive exponents. So we'll move the quantity 5 plus 3x cubed down to the denominator, which will make the exponent positive 1/2. But remember, when the exponent is positive 1/2, that's equivalent to a square root. Let's write the final first derivative in the form of 9x squared in the numerator. In the denominator, we have 2 times the square root of the quantity 5 plus 3x cubed. So notice how we ended up with a 2 in the denominator and also the square root of the quantity 5 plus 3x cubed. And now let's find the second derivative, which means we need to find the derivative of the first derivative. To do that, though, we will use this form of the first derivative where we have the function expressed using rational exponents. Notice to find the second derivative, we will need to apply the product rule, which is shown here in the upper right-hand corner. So the second derivative is equal to the first function of 9/2 x squared, and then times the derivative of the quantity 5 plus 3x cubed raised to the power of negative 1/2. So we multiply by negative 1/2, and then we subtract 1 from the exponent. Negative 1/2 minus 1 is negative 3/2, giving us 5 plus 3x cubed raised to the power of negative 3/2, and then times the derivative of 5 plus 3x cubed, which we know is 9x squared. And then we have plus the second function, which is the quantity 5 plus 3x cubed raised to the power of negative 1/2, times the derivative of 9/2 x squared, which is equal to 9/2 times 2x. I now need to simplify. Looking at the first product, notice how the coefficient is going to be 9/2 times a negative 1/2 times 9, which is negative 81/4. And then we have x squared times x squared, which is x to the 4th. And we still have the quantity 5 plus 3x cubed raised to the power of negative 3/2. And then we have plus. Here, 9/2 times 2x is just 9x, giving us 9x times the quantity 5 plus 3x cubed raised to the power of negative 1/2. So this is the second derivative. Let's rewrite it using positive exponents and then using square roots. Using positive exponents, we would move the quantity 5 plus 3x cubed down to the denominator, which would change the sign of the exponent here as well as here. So this gives us f double prime of x is equal to, we would have negative 81 x to the 4th in the numerator. In the denominator, we'd have 4 times the quantity 5 plus 3x cubed raised to the power of positive 3/2 plus 9x over the quantity 5 plus 3x cubed raised to the power of positive 1/2. We know an exponent of 1/2 is equivalent to a square root. The exponent of 3/2 is a square root where the quantity 5 plus 3x cubed is raised to the third power. So let's write this one more time using square roots. For a quick review on what's going to happen here when we have something raised to the 3/2 power, if we have x to the power of 3/2, this is equal to the square root of x cubed, which does simplify because x cubed has the perfect square of x squared. X cubed is equal to x squared times x, which simplifies to x square root x. So for the quantity 5 plus 3x cubed raised to 3/2 power, this will simplify to the quantity 5 plus 3x cubed times the square root of 1 factor of 5 plus 3x cubed. And then we have plus 9x divided by the square root of 1 factor of 5 plus 3x cubed. So the first and second derivatives can be expressed in several different forms, but since the original function is given as a square root, we would typically express the first and second derivatives using square roots as well. In this form for the first derivative, and in this form for the second derivative. I hope you found this helpful.